Okay, so today we're going to practice representing linear relationships in different ways. So here's some examples we're going to go through. Um, the first one, we're going to get a verbal description. All right. So, Elena, would you mind reading this verbal description for us, please?
A baby giraffe measures 6 feet tall when it is born and grows an average of a half foot each month. What is the relationship between X, the number of months, and Y, the height of the giraffe?
Okay. So in this case, they're giving us the information in a written format. Uh, let's just highlight some of the things and maybe identify what they are. Baby giraffe measures 6 feet tall when it is born. So if you have a highlighter, some way to underline that, that would be a good idea. And grows an average of 1 foot each month. Grows 1 foot each month. And I don't want you to discount this information. What is the relationship between X, the number of months? So they're telling us what to represent with the variables. X is going to be the months. And what's Y going to be? The height of the giraffe. Okay? And we want to write this linear relationship in multiple ways, starting with an equation. So before we do that, let's just identify what these numbers might mean. Okay? Um, so I'll get you started just to give you an idea of what we're looking for. 6 feet tall when it's born. That's the y-intercept. That's our starting point. So if they're giving you some place to start, an initial value sometimes we call it, that'll be our y-intercept. How about the 1 foot each month? Yeah, it's more of a rate or a slope. So you can call it a rate or a slope because that's what it is, 1 foot per month. So we can call it a rate or slope. And really, they gave us everything we need to write an equation in the form y equals mx plus b, to the point where they're even telling us to use x and y. So who wants to give us an equation this might be? All right, Gabriel? Y equals 1/2 x plus 6. Now, I have a question. Instead of using 1/2 as a fraction, can I use 0.5? Yeah, that's perfectly okay. If you used 1/2, that's fine too. Even on the answer some of you gave me. Some of you gave me decimals. Some of you gave me fractions on I think where we were asking for an equation, and that was okay. Either format, as long as it was correct as a fraction or as a decimal, it was acceptable. Okay, so let's move forward. The next thing we want to do is represent this as a table. So we're going to process the information. This is what we do when we process. So we can do like 0.5 on month 0 would be 0 plus 6, which would be 6. And then we could do that for month 1, 0.5 times 1 plus 6, which would be 6.5. And let's just continue doing it to fill in the table. That would be 7. Okay, and that would be 7.5. Wow, that's grows a lot. Now, let's go ahead and plot some of these points. So this is our x value. This is our y value. Let's make some points and graph it. So we're going to start at 0, 6. I think I'll skip over and do 2, 7. And 4, 8. And 6 and 9. And I can even go beyond that, right? What would it be at 8? What would the height be at 8 months? 10. You just go up 1 across 2. Okay. Now, this is going to be what's called a continuous graph, meaning we measure the height, right? So it continues forever. So we don't want to just put the dots. We want to connect them. Because it doesn't just, the giraffe doesn't just magically go from one height and the next month go to, in between it's growing in small increments. Okay. Any questions? So that's what multiple representations are. We had a verbal description. We were able to make a function, and then we made a function table from that, and then we were able to graph it. Let's move on and answer this. All right. So I'd like you to. How did we find the ordered pairs to create the graph? How do we find the ordered pairs? Where did it come from? The table, right? The months and the height from the table. From the month for x and height for y on the table. Okay. All right. Jose, you told me the slope was what? 1/2. That's what they're asking here. What is the slope of the graph? 1/2. What does it represent, guys? Inches, it grows every month. Per month. Okay. So let's see here. Who can raise their hand and tell me what is a y-intercept of the graph and what does it represent? Ivan. Okay, so it's 6, and it's how big the giraffe was initially. Okay, So the giraffe's initial height, let's say that. Two F's in giraffe, right? That's tall. Then again, it is giraffe. Okay, so I want us to understand this next question. Uh, because on the test, you're going to have questions like this. What does the ordered pair 9, comma 10.5 represent in the top context of the situation? In the context of the situation. So in the world of the height of giraffes in this particular problem, 9, comma 10.5, what would that represent? What's the 9 represent? The month. How about the 10.5? The height in feet. So 9 is the month. 10.5 is the giraffe's height in feet. Look how thorough I was. Okay? Look how thorough I was. You got to even specify, okay, it's a number, but what's the context of that number? Yes. Oh, thank you. Yeah, that would be bad. Again, that's not an understand, or I understood the context. I just put in the wrong units. Okay, thank you. Okay, if the giraffe is 12 feet tall, how many months old is it?
12 months old.
Yeah, we want it to be, well, every 2 months. Would it be accurate to say every 2 months it grows 1 foot?
Yes.
So then after 8 months it's 10 feet. So it has to grow 2 more feet. How many months would that take? Yeah, it's going to be another 4 months that we have to add to the 8, so it's going to be 12 months. So you can use any number of, you got all these tools now to figure that out. We could start, okay, it's 8. I know that every 2 months it grows 1 foot, and we have to grow 2 more feet to get to the height that we want. So let's just say, so what's for 12 feet, it has to be how old? How many months old?
12 months old.
12 months. Wow, 1 year. Wow. 1 year old, basically. Okay. Any questions? Let's try the other one. Because your assignment's going to be to work out one of these just like we did on your own. You ready? Oh, okay. All right. So use the given information for each situation to fill out the missing representations. Okay. Let's take a look. From the context here, we want to fill in everything. As far as I can see, they're telling us the equation, although it's kind of a little mixed around. You see how it's written? Kind of bothers me. I'm going to rewrite it if you don't mind. Y equals 1.5 x plus 12. I see why they wrote it that way, but just from the context, what do you think this whole situation that we're going to work on, what's it all about? Pizza. Joey's Pizza Parlor. Okay, first clue is from the graph. It says Joey's Pizza Parlor. And let's look at what we're measuring. What are we measuring on the x-axis? Number of toppings. What are we measuring on the y-axis? The cost. Okay. All right, so let's see. It says X number of toppings. So X represents, well, I don't think, maybe it's not 1.5 toppings, but it is related to that. Okay, so X is the number of toppings. I got that from the graph. What does Y represent? The cost. You see how I'm getting that? I'm looking at the graph. Also here, look here. Number of toppings and the cost, where X and Y would be. Okay. And we know it's 1.5 for the rate. And the rate is always Y over X. Y over X. So what are we measuring on Y? Cost. What are we measuring on X? Toppings. So what would it be, guys? Put it away right now, please. I want you to think about this, because if you get a question like this on the test, you won't have me to help you there. Y is the cost. X is the toppings. What's Y over X? Don't think of a number. Think of what we're measuring. Cost and toppings. Cost and toppings. What's Y over X? Cost over toppings. So what are the units? Dollars and number of toppings. So it would be dollars per topping. So the slope represents the dollars per topping. How much money is it per topping? 150. You see how we figured that out?
Yeah.
Okay, it's $1.50 per topping. We just figured that out. So it's $1.50 per topping. What do you think the 12 represents? Yeah, the initial cost for the pizza. You've been to a pizza place, right? You can get your basic cheese pizza for a certain amount, in this case, $12. And then it's a certain amount, in this case, $1.50 per topping. So that's the description, maybe. Let's put it all together. Let's put together our description. At Joey's Pizza, it costs, let's start with a pizza. How much does it cost for the pizza? $12 for a pizza. And $1.50 per topping. I don't have much room, so basically I'm gonna leave it at that. Okay. So that's how we got this. It's $12 plus $1.50 per topping. Okay, and X is the number of toppings. So this function or equation would tell us the total cost for any number of toppings. Okay, So let's go ahead and fill that in. So it would be 1.5 times 0 plus 12, which would be $12. Oh, just leave it there. Then we have 1.5 times 1 plus 12. How much would that be? $13.50. I guess I should put 0.00 here since we're talking about money. All right. Then this would be 1.5 times 2 plus 12. That would be $15. Okay. And this would be what, 16 and a half? Okay. And that would be 19 or $18. 5 toppings. Wow. That's a lot of toppings. How much would that be for $21 for a pizza? Well, maybe it's really good pizza. But 6 toppings, that's a lot. All right. Is one of those toppings pineapple, I wonder? Ah, some of you are those can't have. Yeah, well, it's pizza. However you like it. Okay, let's make a graph then, guys. Um, so let's see here. Where are we starting off at? What's our starting amount? 12. Then we have 1350. Then we have 15. And at 3 we were at 1650 and 18. And at 5 we were at 1950, right about there. And at 6 we were at $21. And we could just keep on going. Like so. Now, do we connect the points in between? Do we connect the points, do you think? Well, let's see what that means. What are we talking? It made sense to connect the points on the previous one because it's what we call a continuous graph. When you're growing, you measure it, right? You measure the growth. Here we were talking about months. And here we were talking about height in feet. So it made sense here because you don't just magically grow a foot, right? It's a process, it's measurement. Here, we're counting. We're counting things. And you don't, in other words, you don't go from this and have an in between topping amount, right? Can you have 1.5 toppings? Not really, right? So you jump from one to the other. So this one is discrete. You don't actually connect them. Okay? All right. So I'd like you to try this one. Look at what we're measuring. Look at what we're measuring, guys. And let's see if we can't figure out what's going on. Smith family road trip. So let's see, gasoline remaining in gallons. Gasoline remaining in gallons. Okay? And they actually gave us here some values in the table. So let's see here. What are we measuring? What are we measuring on the x-axis? Miles. What are we measuring on the y-axis? Gallons of gasoline. Okay. So what would our rate be? What would our slope be? What's y over x? We're measuring gallons. Yeah, gallons over miles. So it would be gallons per mile. Gallons per mile. And it's gallons remaining. Let's just plot a few of the points and see what we get. So let's see, 10 and 8.5. So here's 10, let's put 8.5. Put a point there. 20, here's 20 and 8. 20 and 8. Okay. 30 and 7.5. Here's 30 and 7.5. Okay. And 40 and 7. Here's 40 and 7. Okay. And 50 and 6.5. 50 and 6.5. Okay. I'm just going to connect these because this is continuous. How many gallons did we start off with? 9 gallons. Do you see how I figured that out? Got that from the graph. Haley, you were going to ask something or were you going to share something? Uh-huh. Yeah. So you're already at finding the slope, which is the next thing we were going to do. You notice that you go down half a gallon every 10 miles. Every 10 miles you go forward, it's down. So let's go ahead and figure that out. What would that be? We have negative 0.5. That's a difference in y over 10. So if I divide that, what am I going to get? If I want the unit rate, I want negative 0.5 divided by 10. What's that give me? Negative 0.05. So you lose 5/100ths of a gallon every mile. So you're losing 500 Basically, you go down 5/100ths of a gallon every mile, and that's our rate. Okay, so let's just see if we can get an equation from this. We have a slope, negative 0.05. We have a y-intercept, which is what number? 9. Okay, so basically that was 9 gallons. So for the family trip, how many gallons of gas did they start with? 9. And every mile they lose how many gallons? 5/10 of a gallon. Okay, so let's go ahead and write that down. Okay. On the Smith family trip, they start with 9 gallons and go down, lose, I'm going to say go down. They decrease, you could say that, 0.05. I don't need to put the negative because I already put the words go down. That's our negative right there. Gallons every mile. All we need is our equation now. Y equals, help me out. Y equals what? Yeah, we got our M and our B. All you got to do is just put them in there. All right. So today's assignment is going to be a CAMI assignment. I have the paper copy for you. I'm going to pass those out right now. But it's basically one problem just like this. Okay.